I am in Bethnal Green, in London, in this eastern part of town, and I'm about to meet with Prass. Prass is a machine learning expert, person very knowledgeable about developing platforms, about working with machine learning systems, and I'm looking forward to have a long conversation with him. Let's see how it goes and how we can have this in a cafe in town. Let's get started. Hi everyone, today for AI Product Engineer, I'm here with Prass.
Hello.
And this is our first episode of the Becoming series. Will be Becoming Prass. Prass, you are a machine learning platform engineer, right? Or how will the exact title that you are?
Exactly. So that's probably a loaded word. So machine learning platforms is so I was a machine learning engineer. Now we're building out the platforms
Mhm.
for the entire machine learning stack. That's the way I got into machine learning platforms. It's a term that we did not use in Superpower before, and I thought what best would suit the MLOps engineers who are joining the team. And the best term, in my opinion, was platforms because we're doing more than traditional MLOps and we're looking at DevOps and data. So,
Okay, so let's start by understanding. So you say there is platforms, there is also MLOps and so on. So where would you draw the line between these different disciplines?
in principle, our skill set is MLOps, DevOps, and data. When it comes to drawing the line, it depends on how you think about it. So it's the same skill set overall. So if you are setting up processes,
Mhm.
pipelines for machine learning end to end, then I would call it MLOps.
Yes.
But if you're building the tooling to make sure those pipelinings is scalable, those processes can be repeated from repository to repository, from project to project,
Mhm.
such that it requires less time for you every time to do this. So it's meta MLOps is what I would call platforms engineering.
You have very, let's say, sophisticated understanding of these nuances. And this shows that you have been doing this for a very long time. So let's start from the very beginning. How did you study Prass?
I surprisingly didn't study anything in computer science. I didn't study
Science,
not computer science.
engineering, and
Yes, I did electronics and communication.
okay.
That's where I got a good understanding of signal process.
Wow.
Signal processing got me into image processing because image is another signal.
Plus.
Then I went into research. So I went into deep computer vision research for 4 years.
Okay.
Came out of research in 2016, 2017.
You thought I was doing a PhD about going the academic path?
Yeah, so I started doing a PhD and then I quit my PhD. And some people will say, why did you quit so late? Because I spent 3.5 years doing a PhD and then I quit. The only like advice or knowledge I would give out there is be very intentional while you do your PhD.
I agree. Yes. Yes.
Just figure out your reasons early on.
Yeah.
Because for me, my reason was always to work in the industry.
Mhm.
It was never to do academia.
Okay.
Uh, the PhD would have been a knowledge boost.
I see. Have you read the book Siddhartha by Hermann Hesse by chance?
Herman Hesse, Siddhartha, yes, yes.
Always I say a PhD is like that book. Why are you telling me? You agree? Would you say it's different?
No, I would agree. I would agree. I think there's two sides, right? Like I'm not blaming anyone who's doing a PhD. I absolutely love like the people who are doctors and stuff like that. But sometimes it becomes into a race. You're racing for the race, not for the goal, and just be conscious about that. And if you think you're doing it, just figure out what you're doing it for, and just make sure that's clear with you.
What was your motivation to the PhD originally? So you say I want to be a professor, or what was that?
Surprisingly, it was just for knowledge. So I just wanted to learn more. I knew very little about the field.
Yeah.
So I did not know much about computer vision. So I wanted to learn more. And so I started doing the PhD. And then soon enough, I realized, not soon enough, late enough, that I could actually get practical experience in a job better than a PhD.
No, it really depends on the system because, for example, say like in the UK, let's say 3.5 years will be, let's say, like late enough. When you're talking about the US and so on, maybe like Australia, 3.5 years is almost like at the beginning, the middle of the PhD, right? Sometimes people can take like 8 years and you'll be okay.
And sometimes it's your life work, right?
Yes.
And especially when it's your life work, I think that's the beauty about doing a PhD. When you focus in and you want to give back to the community substantially more than you got from the community. I think then the PhD becomes beautiful.
Yes. Are there any tools or frameworks or ways of thinking that you took from the PhD and still you might use it today?
Lots of them actually. So this is where the PhD helped me out a lot because it gives you the space to basically think. Right?
Yes.
Like in a daily job, you can't think so much. So the biggest one I got was breaking down a problem into its constituent parts, the logical parts. So system design
Design.
improved a lot because of PhD. And also I was researching a lot about random fields. So that research just stuck to me for the rest of my life.
How about your programming skills? Did they get better in the PhD or was it more like spaghetti code and just some small scripts here and there?
A little bit of both. I got deep into a lot of language frameworks. So I got deep into Python and C++ during that time. My C++ skills surprisingly improved dramatically. Um, Also, but I was not exposed to standards, conventions. So what I thought was good code was barely good code for the industry. So uh, like code was good. The conventions and the standardization part of things
Yes.
was still not, I couldn't practice idea I got to. That improved as I got explored different internships, different companies. Then you understand what is acceptable, what is not acceptable.
Yes.
So pretty much the first unit test I wrote was after the PhD.
So when you started PhD, you knew some programming from your classes. Like I said, like normally first year of university undergrad is some introduction to like Java or C, or these days a little of Python. So that's where you were, right? So you were not really like a programmer, but you were like dangerous enough to do things.
Actually, I've been programming since 5 years old.
Okay, so you programmer since day one.
Yeah, since pretty young. So I've been programming for a long while.
What were you programming? Like when you were like a child?
So the reason I got into programming was DOS.
Okay.
I used to play DOS games, and then the cheat codes used to be command line arguments.
Yes.
That's what got me. So I started scripting, and then learning web, so HTML and stuff like that. And then it got me into deeper programming languages like C++ and Java.
Yes.
Then by the time I was 15, I could write and talk in C++, Java, a little bit of Python.
This was the early days of the internet. And also, of course, there was not like today, there were like communities and so on. So books and which books were they? So like so were they O'Reilly books or which other books were that?
I don't remember all of them, but my favorite ones were the For Dummies series.
Yes.
Absolutely beautiful and absolutely great to get started.
So jumping to effect to today, so someone who says, I'm also trying to learn and so on, of course, now it's completely different. Do you think there are like better sources? Do you think still books are like the main source to get good at coding? Or do you think by now there are other paths that make more sense?
I think there are other paths. I can actually talk to you about a friend of mine.
Yes.
Learn coding from ChatGPT. So if you wanted to know how to make AI agents,
Yes.
absolutely no coding skill. Came from a product background. So
Yes.
some concepts around software, but not coding at all. He learned Python from ChatGPT. So basically by the beauty about these chat-based interfaces is now you can ask it questions, make it more interactive, and
Yes.
just make it like it can get down to the level you are or get up to the level you are. So it's very dynamic, and I like that.
And some questions I have heard about work on ChatGPT are two. The first one is it makes you lazy because you're no longer really thinking, but you're just like copy pasting what you are getting. And the second one is that in the end, this really helps when you already know what you want. And you can really call and say, hey, this makes sense, this doesn't make sense. Because for example, ChatGPT is trained with a lot of Stack Overflow questions and so on. And then there you also have a lot of things that either don't make sense, or maybe they're based on older versions of an API, maybe the way of doing things no longer like state of the art. Maybe, especially like you see like in Python, if I think about like data like pandas, a lot of questions that are on Stack Overflow for pandas, they use very slow ways to interact with pandas. And then if you ask to ChatGPT something, let's say like Python pandas related, you might not getting this type of thing. So only if you're already your eyes trained and can see, hey, this doesn't make sense, you can either tell to ChatGPT or correct it yourself. Is your friend able to now? So where your friend at the moment in this path?
So it depends, right? Like it depends what you want from your learning process, right? Some people want to go deep into a language. Like for example, if I'm about to learn Rust as a programmer, I want to really understand Rust. and I want to go a textbook way with it. But for some people, programming is a means to an end. And the faster you get to the end, the faster you get your dopamine hit. Like you see, my first application went live, my first web service went live. Doesn't matter if it's good code, bad code. Doesn't matter if it has bugs, it doesn't have bugs. Because the moment you get all the way to the end, then you know where you can focus, go deeper, and then you understand, hey, I can do this in a different way.
Yeah.
I remember my first C++ code was the same way. It was to calculate income tax. And
How do you go from those games to income tax? Oh, or like the big gap, right?
I mean, there were like years in between when I was young, but then it went into income tax, and then I was like, "Look, ma,
Yeah.
I can make income tax." For me, that was my first dopamine. Having your first website, having your thing that does something. Then you can go deeper into understanding. Oh, this is a forwarding. Oh, this is how I import from another package. Oh, this is what Trip really does.
Yes.
Sometimes you just copy paste what ChatGPT tells you, but then in my opinion, you don't really need to know till you get to the end.
So if you were now to learn again to code, so you start with C++, or your first programming language, how would you learn today? So you have now mentioned Rust. Will it be Rust? Will you Python? Or how would you choose today to learn as a first programming language?
I think I'd stick with Python because Python is one of those languages which gets out of the way. If there's anything that I want to learn first, it's to do stuff,
Yes.
to make the programming language do things. And Python is a really great language for that. Then, if I like the concept of languages, then I would go into something more structured like C++.
Python also has characteristics can be like so object-oriented language, like pure scripting, pure like more like functionally oriented. So it's a very flexible kind language that allows you to do many things. How will you learn Python? Will you like learn it a specific way? Will you learn a more object-oriented approach or more like a data processing function-based approach?
Maybe like my way, let's say I'm starting today, would be to build a website. Start with Python, start with something as simple as Streamlit.
Okay, so
It's a Python library, make some simple stuff that does for something, like maybe queries an API, gets you some results, like just chaining maybe 100 lines of code.
okay.
At the moment you can put it up and you say that, oh, shit, this actually does stuff. And then you can go deeper, is what I would say.
So then going back to, let's say, so you were in your PhD 3.5 years, so you got quite good, so working with, so programming and so on. I imagine that time, computer vision and programming would have been still a lot of C++, or was it already Python centric, your word code, your code base?
Sure. As you mentioned, it was a lot of C++ in the early days. So Python was really picking up,
Yeah.
actually learning at that point of time. So the first few years of neural networks, they were all built in C++. You did have amazing Python libraries like scikit-learn already. You had scikit-image. You had NumPy.
Yes.
And that made batch processing way easier in Python than in C++. So I started seeing the transition of people using Python instead of MATLAB. I think that was the big change when Python replaced MATLAB.
Yes. Because you were studying signal processing, and I remember that MATLAB was like huge for all this type of stuff, right? Signal processing, also engineering related workflows and so on. So I can imagine also you were very strong in MATLAB.
Used to be strong. I think that's snowballed the case. I did MATLAB for maybe 2 years of my life.
Yes.
It was a janky, it was a big IDE with a bolts attached. So it's not always easy to work with.
Would you recommend MATLAB still today? So do you still see a place for MATLAB, or you think, okay, now everything's on Python or on Julia and so on, and MATLAB doesn't really fit anymore into this world?
I'm going to be opinionated. I think MATLAB does not fit into the world. Like at least MATLAB, the way it is, does not fit into the world. Like if MATLAB was a proprietary set of libraries for Python, I think it fits into the world. But with the Anaconda stack, you absolutely don't need MATLAB anymore.
How about Julia for engineers? Have you explored it? You think it's interesting?
I've not explored it. I think it's a beautiful language. I've heard a lot about Julia. I think the biggest issue with these new languages that try to rethink the way you do things, they might be beautiful languages, but the ecosystem is not there, and it becomes a chicken and egg problem.
Yes.
So I think Julia's ecosystem is growing. that is a great thing. I think we need more languages in the space. We need different ways of thinking because it's very easy that if you think Pythonically, you continue thinking Pythonically and you cannot borrow ideas from other places.
See.
So I think that way, it's always good to have more players in the system.
You say, okay, I will not pursue my PhD further. And you say, we thought, what's next? And what was next?
What was next was a series of jobs. So this was when I was in Spain. So I worked in HP for a bit. In HP, I was an image processing consultant. So we got down to the printer. We were doing image processing on the printer, which was an amazing experience. Like all the different way to do image processing on an embedded system
Yes.
was a beautiful experience. And also to know how some things are the same, embedded or not, and then some things are absolutely different. Like your memory budget becomes absolutely different. But you can even still have Python on that. You can have NumPy on that, but your memory budget is limited.
And I want to ask about that. So, has it informed your way of developing code today, working with these constrained systems where we were talking about these digital printers? They are like deployed in an environment like a print shop that potentially have internet access, also will be operated by non-technical people, and also, of course, are not heavily so sophisticated, advanced hardware deployments, but it's rather more like on the verbal side. And you have to do it like sometimes like really embedded programming. Do you still take some of that today in your work, or you say, okay, now I have unlimited resources, I do whatever I want?
So I look at this kind of optimization for embedded systems as an optimization layer. And I think there's a place for optimization and there's a place for moving fast and not optimizing. And both of them, you got to choose which one you want to use at what point of time. To be fair, currently my mindset is more move fast, optimize later.
Yes.
But maybe someday I'll come back into the optimization side.
When do you know that it's time to optimize?
Um, Actually, that's a very good question. So the way I look at it is what, how much are you spending, right? It comes down to money at the end of the day. Money and latency.
Okay.
Uh, how much are you on your model, on your application, on
Yes.
your system? Do you want to reduce it? Do you not want to reduce it?
Yes.
And what cost is reducing it going to come at? Because sometimes reducing it comes at the cost of opportunity cost. So you move slower. So you have to be conscious that you account that into the equation. So if you do optimize, you're going to lose some time in optimizing. There's going to be some stages to productionizing. You're going to create some guardrails as well because you're going to go smaller. So you need to know that. And then at what latency cost? Like, is it going to give your users a better experience? And that should drive it. Like, if it gives the users a better experience, go optimize like crazy.
I see.
Because this has amazing value. But if it takes you 1 year to optimize, and then like Mistral next model comes by, then it's not worth it. But if it takes you 1 month to optimize, then you should do.
And well, working for HP in this digital system for print, it was rather close to where you were doing at the PhD. You were there for a time, but then what happens next? How is it that so when did this jump into more like machine learning related task came?
I think so. I was always doing machine learning. In HP, it was more oriented towards images.
So which algorithms or methods were there so for that?
It was very basic signal processing level because at the printer you have the images that are being printed, and you have certain sensors to see whether if the print is happening as expected. So basically, calibrating those sensors was one of the things I was doing, and making sure that the printer health stays well over time. So it's almost like machine quality optimization.
She was that.
This was 2017,
Okay.
all the way till 2019.
Okay. So back then, of course, it was already the whole digital revolution. Of course, to CNN and so on, they were well established and so. Were they already used at an embedding system level? So would you already have to do with CNNs or other type of deep learning so workflows in this type of environments?
Yes, yes. So not so much on your not so much at the printing level, but at the entire printer level. So the printer had multiple things like scanners, copy machines, and stuff like that. And at that point, you could start looking at using the scanner more effectively,
Yes.
using using the printer in tandem with the scanner while you're making copy. And I would say, like, at least at that point of time, I was in the first generation of exploring deep learning ideas. Uh, and also, this was for 3D printers as well. So they needed to figure out how well they printed something. So
Yes.
this was first generation. And then as I left, it's improved. Like, I can see certain things now in today's printers that probably came out from that time. Yeah.
So
Not by me,
and I
at that time. Yeah.
interesting. I remember so there was a discussion some time ago between Elon Musk and Jan LeCun, where Elon Musk was saying, "Oh, like we don't use CNNs anymore, like outdated." And then Jan LeCun was saying, "Oh, you really know what you're saying because so pretty much when you're talking about embedded systems and there is some sort of machine capability, there is almost always a CNN. And I think so because CNNs are such a, let's say, like a low overhead algorithm that can be analyzed, they can like really scale very easily and can fit into these very constrained environments."
The way I look at CNNs is exactly like that. So CNNs are a fancy way to stack multiple filters, right? And filters work really well with images. And you can customize those filters as you're training the model. And you get down to this nice embedding that you can use with any HUD. I think they fit really well with images. The way I look at it is, again, there's filters. And if you look at like a ResNet that's trained on ImageNet or something, the first layer of filters actually look like the ball filters in our eyes. So they work quite similarly to how our eyes work. And that's a signal that it naturally mimics what like how we process imaging.
Yes. And so you were not working with CNNs, which algorithms were you using? So at HP?
In HP, it was the early days. So we were working with the basics, the very basics like BGGNet and stuff. But also before, it was almost before CNNs could make it to embedded systems. So we were working a lot with manually constructing those filters, training it using machine learning, but not really a convolutional neural net. More like filtering, feature extraction, and then something. So just like one layer, two layers. So not too big to be called. But funny enough, you talk about CNNs. My next job was completely on CNN.
Okay.
It was all the way just CNN, CNN, CNN.
So you stay at HP for a couple of years and then so next year CNNs, what was that about?
That was actually face recognition. This was in Belfast for 2 years. I worked in a company called Anyvision, now called Ustal.
Yes.
I used to be an applied researcher there.
Yes.
And it was the entire stack was CNNs.
What were you doing in your PhD?
I was doing semantic segmentation, also with images.
Where? Which university?
This was in Barcelona, in Spain.
Okay, so you studied in Spain, also undergrad in Spain, or what was it?
Undergrad in India,
Okay, undergrad? And
masters in the UK,
okay,
PhD in Spain.
yeah,
So that was 6 years, 4 years PhD, and 2 years working in HP. And then I come to the UK.
why Spain? Was it because like the PhD was there and say I go there, or is there a reason?
It was this particular center. So in Barcelona, you had a center called Computer Vision Center,
Yes.
which was a collaboration almost of 4 universities. And it was a Catalan funded project and a Spanish government funded project. So it was very well renowned, very well funded. And you could see that good people came out of CVC. So I think it gave me a lot of foundational knowledge in the
Yes. Yeah, I know quite some people who were like a Pompeu Fabra, so for computer vision also, so it was like a tradition, it was very, very respected.
yes, definitely.
And then, so you finish here, so it's in Spain, and then you say, I'm tired of Spain, and maybe Belfast, maybe something new, or it was just beautiful jobs, or how come different country, different...
It's a bit of all, right? So it was, hey, I need a change. It was I want more money to grow in my career. Like, money is a big driver, and I wouldn't not say that it isn't. And three, also explore the world of startups.
Mm.
So Spain did have a startup scene, but most of them in Spain were not as well funded as the UK or US for that matter. UK had a thriving startup scene. So ever since then, I've been in startups for the last 5 years.
Was there a reason why they didn't say, hey, I stay in this more like corporate environment, large organization, and so on? Why come this drastic shift from a huge organization to a startup?
It was just the life cycle of projects, to be fair. I remember I built something in my first month in HP. I'm not saying anything about HP here, but I built something in my first month over there, and it took me about 15 months to bring it into production.
Mhm. 15, wow.
15 months. Uh, and basically, it's just conversations, and you build it early stage. Like printers take time to build as well. It's a prototype. You go through multiple stages, so that's fair. And through that, you're constantly testing your software, stack, and everything. So it does take time. And also, it was a hardware driven business. So hardware takes time, unlike software. In software, you can ship, 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 ship. In hardware, you can't really ship, ship, ship. You need to plan out your production line and everything. So then I was like, okay, I need something where I can get a fast response on whether this was good or bad. And that's how I started looking for that.
Mhm.
Also be exposed to multiple fields. Because, for example, like I did not have a PhD at that point of time, and a lot of people were looking for doctors.
That's true. That's true.
I wanted to do the work that a doctor would do, but like I didn't want them to expect it. So this is how I ended up in a startup where I could sneakily do the work that I like to do and then say, hey, this is a POC.
Eh, Basically, there are certain tasks that are restricted to PhD holders. So, going back to the topic of doing a PhD or not, to whom would you recommend a PhD? So, what should be like the profile or the mindset that someone should bring in order to take a PhD? Who is the right candidate, and maybe who should think twice before start doing that?
I'd actually like to hear your opinions on this as well because I don't have fully formed opinions here. My thought process is have some idea of which problem you want to solve,
Yes.
have some idea of the reality of it. You're going to get, it's going to be a publication driven gain. What are you doing the PhD for? Have an understanding of that. And like basically, I would say know what it means to do a PhD before
Mm.
choosing to do a PhD.
Let's have a little break just to talk about AI Product Engineer. If you haven't joined AI Product.engineer, well, you should join the community because we are building not only the AI products of the future, but also we're exploring how to monetize them. How can we generate businesses powered completely by AI? Which means it is not just building apps, but actually building income streams. How can we build single-person AI companies? That's what we're doing at AI Product Engineer. And if that excites you, well, then just join the community. It's free. We have free courses, free resources, free tutorials, and so much more. Come and join our community, be part of it, and let's learn by shipping new, exciting products.
The view I have developed is that if one is not considering to go into academia to become a professor, so doesn't mean my dream is to be a professor someday, then one should really think twice. Because I think that, for example, when you were doing your PhD and also these jobs that you were describing, I agree that there was a time where pretty much you want to get into data science, to machine learning, the market was looking for people with a PhD. But I think that has shifted, and now more and more is even with a bachelor. So as long as you have like experience and so on, in this day you see. So it was also something where I think that in order to do machine learning, it requires a lot of maturity. But first, in your bachelor's, you will not really have anything. Maybe you have some signal processing, linear algebra, and so on. Master's, maybe like the first machine learning class, you will supervise learning, and so. And then really, if you want to do cutting edge, it will be like in the PhD, right?
Yeah.
So then it means as a company in industry, you want to have people who had some sort of exposure to delays and grades, you know, to be PhD holders. But these days I look and then you see all these, even not even that bachelor, so like high school and so on, that they are doing things with cognitive face and like really like fine-tuning models and so on. And I would say, wow, like I never had thought about that when I was in high school at all. So then for that reason, I think that really, if you think, hey, I want to do a PhD just because I need to get a job at, I don't know, like cool job at Meta or Google or so on, I don't think that's the case. Unless you really want to do research, want to be like a research scientist, then you're saying, you say, I really like to publish. Or like another thing, because I think also people underestimate the topic of publishing.
Yes.
So it's like not just, let's say, I have like a great idea and then I code something and write a paper, but it's also you need to know how to market it. You need to know what's like exciting in the community. So how people pay attention to, and it's really like almost like a discipline, a sport on its own. Getting good at that.
I would completely agree. And these days I see what I call as the bedroom hacker, who comes up with models. Some of the biggest decent things, at least in the speech community where I work, are people who have done it either outside of work or at work in a small research institution. And it's not always PhDs who come up with the biggest and the greatest stuff. I think the process of doing a PhD gives you the space exploring the nuances of a particular idea, which maybe you don't get in industry. Like 4 years, 5 years, same idea, consistently, you go deeper and deeper and deeper.
Yes.
If you need that space, I think PhD is great. But if you want to be dynamic, you want to shift, you want to try new things, you want to train new things, you want to deploy new things, I think industry is far better.
In my case, the part was like the opposite from yours, where you were coming from doing long projects and also like this experience was like 15 months and so on. I was like, hey, now I need like a fast-paced environment very quickly. With me, it was the other way. I started with startup. I was always like doing fast things. And then at some point I say, hey, I'm never able to go deep into something. I was always staying like shallow. And no matter how much I like a product, it's always like fighting fires, just like a quenching here is so the problem. And how can I go into an environment where I can spend time, go really deep into the topic? And I was in large organizations, into like corporates. I say, hey, this allows me for that. But still, I cannot really go and focus on ideas that I like, or it's not academia. I push me to do a PhD and so on. But then after that, I say, hey, it doesn't make sense if I want to win academia. Otherwise, it doesn't really make sense to it.
I think the both journeys make sense, right?
And so you were in Belfast up here. So pay for connection that was CNN's was application was like here the pipeline.
It was mostly for security purposes. I think the company partnered with government and stuff like that. So it was a software stack that was not open for everyone.
Yeah.
It was a particular market that was using this. And the main thesis was actually, which I kind of partially agree with, introducing a system actually removes certain human biases when it comes to security, like profiling and stuff like that. Now the system does it for you, and you're not the profiling, but system scans, looks for threats.
Yeah.
And so it was used mostly in a security kind of environment. And then we were adding another layer on top to do analytics, especially for retail, like retail analytics. And that's when COVID came.
Okay.
And I was hired to be a part of that initiative. So COVID came, we shut that down. I went back into face recognition. And then I looked for a change. That's when I did my next go.
And in that time, were you doing also doing in Python, or was it like a TensorFlow, with PyTorch or Keras? Because I remember that in that period, like 2019, well, Python was already so super established in academia.
Yes.
But still in TensorFlow was in the mainstream quite strong. So how were you using it?
It was Python. So
PyTorch, TensorFlow?
PyTorch. So one great thing I learned in that job was the entire machine learning process and stack to come up all the way to a very good, fast, functional model. So we used to train in PyTorch. And this was early days, right? Not many people were doing the entire breadth of work that we were doing at that point of. So we used to train in PyTorch or train in any framework you want. The goal was to come out with an Onyx model, so in an ad. And then we used to spend about a month optimizing that model, quantizing it. So we had multiple versions of the same model. We came up with model versioning way before anyone really was talking about it in the company. We came up with dataset versioning way before a lot of people were talking about it in the community. And then take that model and then deploy it in a highly performant way such that you share the memory buffer in the GPU when you have a series of learners.
Yes.
And for me, I didn't do all of it. I was in a particular part of it, but just being exposed to that was beautiful.
For those who have never heard of the terms Onyx and also quantization. Can you please explain it in specific terms? Because this week I was at a conference, and there's a panel, or one of the speakers at this panel mentioned the concept of quantization, and then the moderator, who was a CTO at a large company, said quantification. I had no idea how was that, right? So often we think, hey, this is like established terms, people know that, but present, sure. The Python is a quantization.
Yeah, let's start with Onyx. So, like, generally, when we train a model with whatever framework, with PyTorch, with TensorFlow, even like scikit-learn or something, you can save the model, you can load the model. When you save the model, it's specific to that framework. So Onyx is just like imagine it like a text file, but it's a model interchange format. So something I convert into Onyx, it's just a format, it's a file format. So something I convert into Onyx, I can load it up in another framework. And then most of the highly performant frameworks used during inference, like Onyx models, because it also converts the model into a self-contained binary that represents the architecture and the weights. And all you need to know about the model is just the input and the output. So as long as you know the input and the output, you can now have this Onyx model on GPU. You can have this Onyx model on embedded system, everything.
So then pretty much Onyx is portability and quantization.
So quantization is just a process you apply either during your training of the model or after you train the model to reduce the bit size of your model. So usually we use floating point numbers.
Yes.
A floating point numbers could be 32-bit, could be 64-bit, could be 8-bit, the new range. And you want to make your model smaller so it performs faster and takes up less memory. How do you do that? The easiest way is convert that floating point into an integer. And that process we call as quantization.
Yes.
And to convert a floating point into an integer, which is a decimal into an integer, you basically need normalizer.
Yes.
So you go from numbers between 0 and how many ever that 8-bit is, and then you say for each number, what's my normalizer? So you basically come down to a very small range of numbers. This is especially useful because some processors that do inference, like actually Intel's processor, they're really good at int processing. So it uses its APU for that.
One of the questions that was at this panel from the audience, so the person was saying, but how does that work? Because I was expected that so floating points is for one, it offers its richness, and then you're saying pretty much like you become some sort of like a binary situation, and you lose all this information. So you have an intuition. Does this work for the audience, for anyone for listening? My conversation is great.
So at the end of the day, you do lose information because it's a lossy mechanism. So your accuracy, whatever metric you're tracking your model against, will not perform as well for a quantized version of the model, and that's a given. But sometimes the loss of that percentage is like if your floating point model is 97% accurate, maybe your quantized model is 93%, and that's okay. That satisfies your product. So yes, it's lossy. Why it's lossy is because you're taking a over-representation of a number to an under-representation of a number. So you are losing information. For example, in face recognition models, the main information we lost while quantizing is the minimum face size it could detect. That would be higher. You cannot detect a 32 cross 32. You now have to detect 128 cross 128.
Yes, something. And you are doing all that in Belfast and the year 2020, right? So
2019, 2020.
So one like really cutting edge.
It was very cutting edge at that point of time.
Yeah.
And this was very valuable experience. It built up my mental model of how a machine learning stack looks for the rest of the years. The only thing I did not have experience in Belfast was deploying to the cloud. It was very low level of manipulation of the models.
Yes. And there you were the only like machine learning engineer. Was it like a team? Were there people more senior than you? What was the story?
There was this was, let's say, me leaning on the shoulder of giants. It was a big team. It was a scale up. So we had more than 50 people just in the Belfast office. And my team itself, we had 3-4 more people. In other teams, we had just the optimization team itself had 10 people.
So 50 was just purely this machine learning thing, plus of course everyone who is machine learning IT people on top on that, or 50 was the whole like team?
50 was just engineers, machine learning primarily engineers, because the Belfast office was the research office.
I see it.
And then you had like one or two DevOps, one or two IT, but it was mainly just machine learning. And that machine learning was broken down into deep research. It was broken down into applied research, which I was broken down into machine learning optimization and then deployments.
Are there other things from that time? Because of course things move so fast, and you say like 4 years is not like a lot, but the same machine learning
It's a lot.
moves so fast. Yes. So which things are from that period do you think, hey, now this is already outdated? And which you say, hey, this has stood this test of time?
So the optimization stack has evolved quite a bit right now. So even the quantization, now you can do quantization away training. So you can do it while you're training itself. That is great.
Yes.
At that point of time, we were reinventing how to do distributed training. Now you can use frameworks like PyTorch Lightning, Accelerate. So prefer to use that. It makes things much simpler. Well, there was a lot of emphasis also on training on your own machines on-prem. Now the world is slowly moved towards cloud, and I think that's a good thing to move fast. And then the fourth thing was also, back to the optimization stack. Now you have automated optimizers. So one of the services is called OctoML, where you can upload your model. It applies Apache TVM on your model and then gives you a simplified binary.
There were this model just acquired by NVIDIA. So and actually they're not longer called OctoML, they renamed to Octo AI, and they were acquired by NVIDIA.
Okay. These were the creators of TVM,
Exactly.
which was the machine learning compiler.
Yes. And if I'm not mistaken, also like the person behind the founder of Kirocamel. So he was the doctoral supervisor of the creator of XGBoost, and there's a whole here like a mafia ecosystem of like massive frameworks for machine learning.
Yes. Sometimes you have those big names in machine learning, right?
Yes.
On one side you have Jan LeCun, but not many people talk about the creator of XGBoost.
Yes, and I would think so. If there is a framework has an impact on whole machine learning, it doesn't work something like XGBoost, right? So yes. There you were still doing all this training on premise, so we were like having some GPUs in the basement, and so it was a transition towards the cloud deployment.
Yes, so that happened in my next job actually. So the next job I moved to Zenith AI, where I was again in Belfast, and I was one of the founding technical members of the team. So went from being an applied researcher to being one of the first 10 people who joined the team. And that's where my growth in like startups happened. So Animation Usto taught me a lot of foundational concepts.
Yeah.
The next one, Zenith AI, is where I got exposed to a lot of tasks in the startup. So we went into model training, we went into model deployments, we went into distributed training on AWS and deployment in the AWS stack. And that's when I learned about the cloud, how to deploy, what are the best practices, CI, CD. So that's when at least my shift from on-prem to the cloud happened. The company shifted at a later point of time, but at least my shift happened at that point.
Yes. You have this very international career where, well, you came from India originally, and then so here Spain, Belfast, now here London. And for anyone who's international, and then as aspiring towards this type of mobility and so on, how can they go about a job, finding these opportunities? So very often what people tell me is it's so hard if I'm based in let's say somewhere like India or in another place that is in the European Union or the US and so on. You're reaching out to the companies, getting the opportunity to connect with them, interviewing and so on. So do you have any secrets or recipes for success?
I wouldn't say particularly a recipe for success. On my side, I had a lot of luck, so thanks for that. But also, I would say, rather than keeping your like applying everywhere and then also being sad that everyone is rejecting you, maybe the nice thing is to find a match, a culture match, a mentality match. Like what are you looking for in a company? You want to move fast and break things, find those kind of companies. Find that through LinkedIn. Sometimes recruiters might contact you, entertain them, talk to them. It's always super useful, especially when you're looking for jobs, to pay for LinkedIn Premium. Like every time I was looking for a job, I paid for LinkedIn Premium and it worked. So 100% suggest that.
Yeah.
And also just be open to exploring ideas. Sometimes you want to go to a specific country, in which case, like, you are zeroing down your opportunity. Sometimes you're open to opportunity. So just figure out what you want to do. If you want to do a specific thing, the whole world is available, and you might find something interesting.
I hear often so from many so who are living from India, for example, they look into, let's say, like the US as the place to go to. But from your experience, are there maybe like hidden gems if anyone from India is listening and then you say, hey, don't focus too much there because maybe it's complicated and also you're competing with so many people. Anything, so let's say like Spain was for you, here the discovery, anything I've seen, hey, here there are like great companies, but maybe not many people know about that, so that the competition is maybe a bit lower.
Actually, one of the things I always wanted to do was not be a part of the rat race. So there are some places in the world where you can beat the rat race. I think some of that is in Belfast, where you could get like a London kind of salary with very low cost of living and some deep research, because you have Queen's University in Belfast, and that has set up that ecosystem for very deep research. You have one pocket, that's Belfast. You also have the Londons and stuff, but the Londons and stuff are also, you get into the rat race. You do have places such as Berlin. That's another one of these where you can balance out the rat race, and this. Canada is one of the other ones. Montreal, especially. Montreal has Mila, which has just funded the
Yeah.
AI movement. Now they are well placed. Lots of startups in Canada. Strongly recommend these kind. I would not recommend countries so much, but cities.
Yeah.
And certain cities have a very good balance of uh, what you want from a city, what you want from a job, how sustainable it is to live in.
No, you're right. For like Belfast will be like this hidden gem. It will not be a lot for me in my radar, but other projects make a lot of sense. It has a very low cost of living, it's very affordable, and so we have a speaking ecosystem. The research side with universities, it's also a city that is, let's say, large enough, not feel small, and let's say like a bit claustrophobic, but also not like a huge place where you feel lost. So,
Belfast has a very fond place in my heart. I should say that.
and you were there now, so you were doing the startup for financial recognition, and then you leave the startup after pandemic. What happens after the startup or scale up actually?
Yeah, so I moved to Zenith AI, and Zenith AI was 2020 that I moved to Zenith AI. So I stayed in the previous startup, which was the face recognition startup, for 2 years.
Yes.
Then moved to Zenith AI, which was a bunch of people from the previous company formed this new company.
Yes.
And I was one of those early employees. And over there, our whole idea was different. So
Okay.
the whole idea was, we looked at the past life and animation, and we were like, hey, we're doing a lot of these things. We're doing a lot of these things manually. Can we rethink it? Can we actually automate it? And can we put the user, the machine learning developer, run? And can we make machine learning accessible for people who don't know much about machine learning? So we went out to build a no-code platform for machine learning to train and deploy models. And it was a little bit like a visual design of like processes. Like, you have this data, you can connect it to a model, and then you can give the model a budget, and it would figure out which kind of model you want, like whether it's a fast one, more accurate one. Then you can train it, and then you can deploy it to the cloud. So we did that for approximately 18 months. Uh, Actually, we did that for 8 months, and then we got acquired.
Great.
And after acquisition, we spent another few months building that. Then slowly we pivoted into genomics-based AI.
So the acquirer was in like this life sciences space, or how from?
The acquirer was in the life sciences space, and the acquirer was looking at. They got really excited in us because one of the no-code projects we built for them actually solved one of their problems. And as a result, they acquired us. And as a result, they wanted more of this. So then we became more pivoted towards life sciences.
Which models were you using here?
We were using a lot of different kinds of models. Like something as simple as random forest was super effective. Also, we were using deeper models like bird style NLP models. In genomics, you have AG, AG, AT. Like you have these 4 letters that repeat themselves. So sometimes NLP models work really well, but sometimes you just want to constrain the model more. And that's when like traditional machine learning works amazingly well.
How was it to go into an industry and also in space where I imagine you had no really exposure, like life sciences, here, genomics and so on. So you were doing signal processing, you were doing also image, some all this image processing. And then, for example, as you were saying, the sequences, well, in the end, they repeat themselves. So it's like a signal of sorts.
Yeah.
Of course, also like images, there is also some connection. Also, you can picture these genes from like a image model, in particular, like a 3D model and so on. But still, you were not like a geneticist, you were not a science space. Was it a challenge to like emerge something like that? Or
It was a big challenge, and I was pretty bad at it as well. I should say that as a person, I do like talking and learning about biology, but I don't like so much like reading the depths of biology. So that was an interesting challenge for me. At least for me personally, I asked myself, what am I best placed to do in this kind of environment?
Yeah.
We have a lot of machine learning scientists in our team who can adapt to this different domain. Do I want to adapt to this different domain? And I basically said, hey, can I basically build my knowledge in the machine learning engineering phase such that it's domain agnostic? And that's why I started looking at more domain agnostic machine learning deployment, machine learning training. So me personally, that's when I grew as a ML engineer and an ML ops engineer because I got more interested and I got the space to do that as well. The ops aspect of the whole machine learning is what is low. That's when I made the career shift into ML ops as well.
Interesting. It's a little bit of saying because this is a space that requires so much domain knowledge and I don't really fit here, then I need to find where I had an opportunity, and it was the platform, the operation.
Yes. And for me, this was always something that I was fascinated by. And I had a very good mentor who was a very good DevOps engineer. Now he heads various teams. So he gave me the direction to think about the cloud in the right way.
Yes.
And then I got this whole machine learning experience that I gathered from the last few jobs. Then I could use these 2 superpowers, and then I made it into MLOps.
Yes. MLOps in 2020, that was very, very early days because I remember that time was still this period where, so you will have pretty much this big divide of data scientists, machine learning engineers that will do, so like some prototype proof of concept, and then they will give it to someone else that will maybe like refactor it and so on. And always will be this not like clear cut division of like task, and it will be not saying, hey, this will be from an end-to-end pipeline of concept all the way to deployment. Will be here, there is this small prototype, and then someone else takes care of a like final version.
Like for me personally, I didn't make that shift in 2020. It took me 2021 to make that shift within the job. So as you're saying, it was quite early days. One thing that's helped me a lot was the MLOps community, which is this global Slack community. And I just used to ask dumb questions, absolutely dumb questions on the community. The community was absolutely welcoming, and it still is. It's a beautiful community. They talk, they might get aggressive, they might be opinionated, but there's so much knowledge that's being shared, so much. And I think the creator of the community, Demetrius,
Yes.
such a very good community manager and community leader, and I should give him a lot of the credit. He also saw something cool around Belfast, and he would bring it to me. And for me, that was the point where that was the knowledge base community I needed.
I hope you are enjoying our chat with Prass. You might be among the 60% of viewers who are not subscribers. And you might be asking yourself, why should I subscribe? Well, by subscribing, you're getting new videos every week, new guests, new tools, new insights. And not only that, you help us to convince many new exciting guests to come over to the show. And it doesn't cost you anything. Just hit the subscribe button, and of course, don't forget to like this video.
Yes. I just take one touch to the community, right? Because I remember that so earlier this year, it was February or March, we're also having some presentation at the MLOF meetup.
Yes. I gave a presentation on how to not go with big cloud on GPUs.
In this book, and then we can see also like in that, right? So where you started doing things on private deployment, then you say, hey, let's go to the cloud and all this cloud excitement. And now you are more nuanced about that and where to deploy to these large clouds, when to go to like smaller provider and so on.
Yeah, it's crazy, right? And your opinions constantly shift as well as you like develop more knowledge or like depending on where your company is as well.
True.
So for me, initially, I started off with the AWS stack. I think the AWS stack is great to fundamentally learn anything about like any of the big cloud providers, AWS, GCP, Azure. They're great to like create things from scratch. Uh, it's great to learn about things like Terraform, which is a way to script your cloud and maintaining and Git version it. And that directly, then you can, once you get those concepts, you can start thinking about, hey, do I need to do it this way? For me, when I started off on the AWS journey, I didn't really know any other way. So that's how I ended up there. And then I went into these all different things. I still like the big three providers, AWS, GCP, and Azure. And the smaller, bigger providers like Oracle Cloud, I think they're all absolutely necessary. But I think the smaller, super small providers like Runport, they have a place in the community just as much as, and I think the big three are actually learning now from the smaller providers. And that's an interesting dynamic that I enjoy.
So given that you've been also for basically like 4 years in this MLOps space, what are like best practices or frameworks or things that you recommend someone starting? If someone in 2024 wants to start doing MLOps, in which I think you will point, for example?
I would actually not even point someone to any frameworks. I would point someone to a mindset, mentality. So I would say, first, know your user very deeply, and your user is machine learning engineer. Like, so for me, the MLOps stack, a good MLOps stack is a good is one which gives you a good developer experience.
Yeah.
And if you're not getting good developer experience from your MLOps stack and it's adding burden, you're doing something wrong. Is my opinion. It's opinionated. Some people might agree, some people might disagree, but this is where I go with it. And then the second thing, after knowing your user deeply, is have the DevOps mindset. So DevOps for me is you're merging the developer lifecycle with the ops lifecycle. So take that mindset to MLOps. You're merging the machine learning development lifecycle and the machine learning operationalized mindset.
What are references?
So generally there are two different. So the traditional thing with DevOps,
Yes.
Pre-2007, was that there was this whole developing process which took 6 months, 1 year. It was great feature, great feature, great feature. And then the operationalized thing was a funnel, which says that this feature is not production ready. So we need to go back. This feature, okay, it's production ready, it performs at latency, it performs at scale. So there was this like passing the feature over the wall kind of approach. And DevOps basically merged that, right? So anytime you start developing features using CI and CD, you're able to quickly test whether it's already production ready, and you codify what it means to be production ready. MLOps, I think, is the same, where as early on in the process, you introduce everything that's required from production. And this could be accuracy tests, it could be some memory budgets, it could be absolutely anything. You introduce it as early on so people don't waste time doing the wrong thing. Instead, they do the right.
Yes.
And at the end of the day, you're just tracking, as an MLOps person, you're just tracking a bunch of metrics.
Yes.
You're tracking lead time to do various things. How much time does it take for me to start working on a new repository? That's something we're tracking. How much time does it take for me to deploy a model once I've researched it? That's another thing. How much time does it take for me to know that my model is deployable? That's another thing you're tracking. So all these metrics for me just constantly got to keep reducing.
Yeah.
And then you give the superpower basically to the ML researcher or engineer to be able to deploy their own models, and then you have a way to protect your production, and that's basically
They like both are figures or pointers. So one is long too long, one is like the optimal zone. So just someone starts doing that for the first time and then it says, so it takes like 3 weeks. Is that too long? Is it too short? Or it depends?
I would say it depends. It depends on where you are as a company. Roughly, let's say I'm just throwing numbers right now, but roughly, if you're less than 100 people developing something, you want that to be as short as possible. So ideally, you want to be able to deploy something within a day, and deploy something ideally within, like, a really good thing would be within 20 minutes. No, like that's your deployment cycle, and that does it. Um, when I say it grows bigger, like let's say you become a company of 500 people, 1,000 people, then you might, I'm relating it to your consumer base, you might have a traffic of 1 million users, 100 million users, and then you want to probably be more careful about what you're deploying. But even then, I've seen some large companies, I've heard about stories in Instagram, for example, where they deploy models fairly quickly, within a day, basically, but they deploy it to a subset of traffic. So the earlier you can codify your practices and bring the culture of deployment, uh, the better it is for you long term. And then, even if you're a big company, you can deploy something within 2 days, and then you can test your traffic, see if it works, and then you can deploy.
And another thing I was thinking about is, so given that you have all these different MLOps, when should a company invest in MLOps? What should be like the size or the maturity? I imagine at some point, so there's always like the first hire and then like some PhD students or graduate and so on, and start doing some machine learning, etc. But when would one do the jump to MLOps?
That's a very good question. I wouldn't say very early. Like, let's say you're just starting a company, you don't need an MLOps engineer. You don't need an MLOps engineer. What you need is someone who can deploy models, train models, especially if it's a machine learning company,
Yes.
and understand the problem space really well. As you're growing into a 5%, 10% company, you at least want someone who holds the MLOps mindset. It doesn't have to be a formal MLOps engineer, because as you scale, you're going to introduce more collaboration. And at each collaboration point, you're going to introduce more technical debt if you don't introduce processes early on. And it's good to introduce concept of pipelines and processes early on into your growth journey. And then you can invest in an MLOps team to maintain that and stuff like that, or build Gen 2 platform for you. So I think somewhere between seed and Series A is the right time to invest in MLOps. Initially, starting off with someone who's a cross between an MLOps and an ML engineer. You don't need a full MLOps mindset. And then as you grow, I think you require more and more of ops.
Yes.
And as you see more traffic as well.
And that also brings the next question. So if like a startup says, hey, we need to start thinking about MLOps, then who should be the first hire? And they're saying, so this is hybrid and
Yes, I think like hybrids have a very good place in early stage in startups. Every kind of hybrid, right? I'm a researcher and engineer, a front end engineer who can do a little bit of back end. That. So early stage hybrids are very valuable for startups, and that's why I say don't get a full on MLOps engineer.
yeah.
You don't want to get someone who's restricting the flow of development. You want someone who's just organizing that flow. So someone with that mindset, who is also doing other things like training models, etc. And then slowly you bring in full-fledged team. For example, in Papercup, they had been just closed Series A, and I was hired as a senior machine learning engineer, machine learning operations engineer. And then I went, built out the team, and I now lead the team, and now it's grown beyond ML platforms into platforms. So this is the entire developer stack, and the machine learning stack now falls uh, under this. So I would say like post Series A was the time where you grow. I think Papercup has done it approximately the right way.
You were at this setup doing so genetics and all these so first steps towards his unlocks, and then Papercup came, or who? someone was sending the phone or
So I was basically in a place where I wanted to hone in these machine learning operations skills, and the existing company I was in wasn't like there wasn't much to do over there. So Paper Cup came in the right time. We started a conversation. I was passive, right? I wasn't aggressively looking for something, so I was passive. But we had this conversation going on, and before you know it, 3 months later, I moved to London, and I joined Paper Cup in 2023 January.
and I mean that when you were like in Despot in this period of pandemic, everything became remote and so on. And you have any opinions about working in a remote environment, hybrid environment, full office environment? How are your preferences?
I like in office environments. I like 1 day focus work by yourself, approximately 1 day a week. So a little bit of hybrid. But I absolutely love going into the office just because when I leave the office, I switch off. And I don't like that when I'm at home because I don't switch off at home. And then before you know it, you take a nap at 2 p.m. So you decide to work at 3 a.m. and my whole life becomes unstructured. So I absolutely love office environments just to keep it in a structured way. Also, when the pandemic was going on, surprisingly, that's when I moved this to the startup. And throughout the pandemic, we actually worked in the office. Yeah, so we got like a special permission and stuff like that, and we went in.
Yes.
Because we were a few people, we were 6 people. So we got an agreement between each other that we will take care of our personal lives. We won't involve ourselves outside the 6 of us.
Yes.
And it was 6 of us, heads down, programming every day. And that was the year I actually wrote like 500,000 lines of code within a year.
What was that for coding? Oh, so it's like
It was building. Yes, it was just building. No noise, no nothing.
Yes.
Everyday building, everyday pull request. That's the whole. Yeah.
And so 2023, you start Paper Cup. For those who don't know, what's Paper Cup?
So Paper Cup is an AI dubbing company. We take videos in one language and convert it into videos in another language. We work predominantly on the speech layer of things, and we do it completely in a machine learning way. The nuance with Paper Cup is that we have a human layer. We call it the human in the loop layer. And this human layer, basically, they are experts in whichever region we are targeting. So if you're Latin America, we have experts in that region. If it's Germany, we have experts in that region. And they know the nuances of the localization into that region. So we basically build our models to be maneuvered by these specialists.
And you do the subtitles and as well as the translation of the audio track?
So it's the main offering is the translation of the audio track. Now we do some added services such as subtitles and stuff, but the main offer is take audio in one language with the video, of course,
Yes.
and get it appropriately in the other language with the right kind of voices, because certain characters, certain voices suit better. Maybe their own voice does not suit them in a target language, and that's what we do.
One of the things I remember, so growing up and watching dub content was that you could always notice the lips were not synced. It's okay, it's not like voice of the person and so on. Can Paper Cup address that, or is something that's impossible to read?
It's something that we're looking into. It's not like we did some preliminary testing on the lip sync, and we found out that lip syncs or we observed, at least in our users, that lip sync is not a major driver. The voice, the voice, the casting of the voice. In traditional dubbing, you cast a dubbing actor to the character. That is super important. Getting the voice right is super important. Getting the words right is super important. And getting it right for that territory.
Yeah.
So I might say, for example, "Cómo estás, tío?" in Spanish in a certain way in Spain. But in Chile, I might say, "Cómo estás, bacán?" And like getting that right is more important than the lip sync, in our opinion.
And this choice of not only accents but also, let's say, like voice profiles, does that happen automatically, or there are like experts who say, oh, like Prass, he has this profile and maybe he will not have, let's say, like a girly voice, or more like a deeper voice and so on? Or is it more like some classifier that you build and then does this matching?
I don't want to reveal too much about how we do, but I'll reveal as
Some
much.
data is manual, like the broad concept.
So I think maybe before that, like one of the things we have is our own library of voices. So we call it paper cup voices. We've collected the data for this from scratch. We have actually paid for the data. We have worked very closely with voice actors, also made sure that they get a good deal out of it, and we built up these library of voices. We have this library is constantly growing. Every month we are adding lots and lots of voices.
Yes.
Now with these library of voices, we have a way to describe the voices internally, like an internal representation of the voices, and we can match it with the source video, the source audio, and we can say this voice is appropriate for this person. However, for us, it's very important to also give the control to the human who is managing the final output. So if the human wants to override the system, they can override the system. So they can choose a different voice rather than what we suggest.
In recent months, there was this controversy also with OpenAI. That I think was with Scarlett Johansson, was that? Or what was that? So this actress.
Yeah, Scarlett Johansson, yes. It was the Sky voice, right?
Exactly, yes. And so, do you have any thoughts of that? So now you were mentioning also like the dubbing actors, these experts who are providing their voice for this library that you're collecting. Where do you stand in all this of synthetic generated voices? So from let's say, like famous people and so on, because I can also imagine that now as the technology gets better and better, well, now anymore you don't need to let's say take like a voice actor, but rather you can take the voice of the person, say like Tom Cruise or like a different person, and then just switch tones such as it sounds Spanish speaking or French speaking and so on, while listening to how Tom Cruise will sound like.
Yes. So I think there are a couple of things over there, right? A couple of things we do differently from the rest of the world. So one of the things, like for example, OpenAI got into a big controversy was they did not really work with Scarlett Johansson, but they still published a voice that was similar to Scarlett. At least for us, it's very important to work directly with the voice actors. We work very closely with the studios to actually talk to the actors themselves. And it's very important for them to know how we're using their voices. We don't do anything under the table or anything like that. We make it very clear to the voice actor, hey, we're going to generate speech from your voice. Is that okay? And we might have certain deals in in place, etc. So that is one aspect, that any voice that we have collected the data. It is not some data that we have taken up from the internet and stuff like that. The other aspect you talk about is voice cloning, like making Tom Cruise talk in Spanish and stuff. I think the 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 consensus on whether this is right or wrong, I think is still like in play. Society is still talking about it. Can it be used for dubbing? Can it not be used for dubbing? Can it be used for particular things? At least when it comes to us, we do not do that. We focus on translating content into paper cup speakers.
Yes.
We do not take the voice of the source at all, because sometimes we work with production studios who don't actually have the right of the actors themselves. So in such scenarios, we might have the technology internally, but we don't do that. The third thing is working with one was on the dubbing, one was on the cloning, and one was on, I don't remember the third thing.
But another thing that I was just seeing all the stuff that you were mentioning was on so the risk of course deep fakes and so on, and then if we can do like Tom
Oh yeah,
voice and
so that was the last thing I wanted to address. So we are not an API product. We are not a SaaS. We do not publish our API to the world for anyone to use. We have a very restrictive way where we vet people who are using our product, and we work with people that we are comfortable working with, because we don't know where this technology can go, and we don't want to be on the wrong side of history. So we are very careful about who we choose. Like one of our big customers used to be BBC, Bloomberg. Bob Ross is one of our big customers. So Bob Ross's Spanish content, I believe it's Spanish, I could be wrong, on YouTube is completely us.
But like his stage, right? Because I think he already passed away some years ago. Oh, I see, interesting. Oh, great. Yeah. And one of the things that's happening with all this discussion of deepfake and so on is that legislators are saying there needs to be some sort of watermarking or some way to see that, hey, this is synthetically generated. And you've been doing so throughout your life a lot of signal processing. Is it possible to encode in the audio track, in the voice and so on, maybe like in some frequency or some pattern, something that says, this is from paper corpse generated, this is synthetic or so, like you tune into that frequency, you will listen to that? Or what could be like ways to maybe like fit these regulatory criteria of imprinting some other markings to the audio?
So audio watermarking has now become a big thing. There are already some libraries. I think there's a very nice library by Facebook. I don't remember the name, but there's a library that helps you do this. And basically, it helps you do it in a way that is not seen in the audio waveform.
Mhm.
So there's almost no difference in the waveform. So you can look at a waveform and say it's watermark, but it can be decoded. So I think the best way to do this is you do it in a way that's hidden in the audio itself, such that you can provide a tool to check whether it's synthetic or not synthetic. But the only, let's say, nuance or complexity around this is that each provider, like a paper cup, has to provide a tool to check it. There's no way you can easily check whether synthetic or not synthetic. But I completely agree. I think we are waiting to, again, be on the right side of the regulation. But I completely agree that someone listening to a particular track should be aware that it is synthetically generated.
What challenges do you face so managing this platform? I know that you're so leading all type of platforms, not only like a machine learning platform, all type of platforms. Do you face a paper cup? So one of the things I was thinking was on just storing all this audio that you are on one side collecting from your library, but also like generating. So sure, it's not as intensive so as video, but still it's not text, where it's just, I don't know, like a few megabytes, maybe like a few gigabytes, but I can imagine it's much larger.
So our data sets go up more than hundreds of terabytes. So it's very important for us to build pipelines that can process that data at speed and also collect data from our production effectively. And also, we don't want to collect too much data because it costs a lot of money. So we set up like life cycles on our data. So if it's not used for machine learning training, if it's just used for observability, we make sure that there's a life cycle. Like some data is just stored for 30 days. Some data we might choose to store it for a month. And that's basically your budget, your time budget to use that data for whatever you want.
Yes.
If you don't, it's over. That means like that data wasn't important anyway, so might as well do. But also, I do think like especially with companies like us and other companies, like we've learned to life cycle the data. But when you don't know, store all the data. That's my like all the data you can legally store and morally store it. Because data you will figure out a way to use the data. For us, we end up uh, building our own kind of feature store for our data, and we can do a better job probably as well. But we built our custom feature store that can serve these features at scale quite rapidly. Within a second of asking for more than 10,000 hours of data, you can get it within a second. So that was very important for us to get that data really fast. And we also built like massive scalable pipelines to process data scale, because we use a mix of human annotation to the data, and custom like automated annotation to the data. So we use a mix of these two things, then we get a machine learning training data.
Which other models are used today? Like I remember, for example, there was WaveNet from Google from audio processing, but this model is from I think like 2019, so it's already a long time since then. What are people using today to process audio data, specifically voices?
Let's say like the legacy stack on text to speech generation was predominantly like you had this 3-layer process. You had something that was a language modeler, and on top of the language modeler, you had an acoustic model. And on top of the acoustic model, you had a vocoder. WaveNet was one of these vocoders. It was one part of the pipeline. These days, I think we call it internally large speech models, because LLMs are not like quite appropriate for what we do. these days, large speech models have been inspired by LLMs as well. So we take a lot of the general concept of LLMs and go directly from text to speech in a single model rather than a different pipeline. And this bigger model itself might have multiple modules that represent that previous pipeline. So you might have a module that represents whatever code it was, but it's a single model now, trained end to end.
So, for example, let's say that I have Tom Cruise speaking English and say, "Hey, I want to sound in like Chilean Spanish to say something." And so, can we picture that first it's necessary to take the audio track of Tom Cruise talking, convert it into text, and then with an LLM, you try to like some inference with some embeddings, and these embeddings have some Chilean voice that will sort of match what you want, and then you will generate the audio track for.
There's multiple ways you can do this. So there are these new family of models called speech to speech. They encode and translation information into the model itself. There's one side of that. Speech to speech models are great, but they come at the cost of less controllability. And then you have like end to end pipelines, which go from speech to text and back to speech again.
Yes.
And then maybe the text you translated. There you have more control. You can correct the translation. You can correct a certain speech. You can choose a certain speaker. So both have their place. So you mentioned the pipeline where you translate, you have some embedding. That's true in the second layer. And the first layer, it's all like internal to the model itself.
One of the things that also you have experienced throughout your career is that when you started, it was pretty much the model is tailored to the task. You will gather your data, you will clean your data, you will train some models, see it works and so on, and then it's for a specific task. Now with all these large models, recruitment models, pretty much we're just getting some cloud, etc. And then we're not really doing any more training. Potentially we might do some fine tuning, but if people do that, the majority is not really working with fine models. Where do you think these are going so as an industry? Do you think that machine learning experts, data scientists, they at some point will stop training together and this will be pretty much everyone using pre-trained models from the cloud and that's it? Or do there will be someone who will be doing things from scratch?
I constantly keep changing my mind about this. So I'll tell you at this point what I think. So one of the things you mentioned that the world is getting into this territory with foundational models that can do multiple things. And then you zone in, you focus the model to do the right thing. I think this becomes very useful at a foundational layer for something that does multiple things. So if we want to get into a world with AGI, foundational models are the way we are going to get there. But I think a world with AGI is still only a part of the world, in my opinion. And you're still going to have scenarios where you need to do things like on-device inference. Apple, for example, has taken the complete opposite route, and almost all their models are on-device. And then it has a layer to do a cloud-based inference. There is a very important thing that comes with that, superpower that comes with that latency. You reduce latency because you're not talking to the cloud anymore, and you're reducing, you're making your data private.
Yes.
And we're going to start using more and more devices, I think, with more and more intelligence and more intimate, like your watch. Maybe you start tracking your health, or maybe you start tracking your speech, your breath, the smell. There's going to be more and more reasons to have your data quite private. And I think that is possible with smaller models, more focused models, and on-device models. And there is going to be a world, I think, where we have these LLMs distilled down into micro models. And there is going to be a world where the LLMs will exist. So I don't think it's an either and an or. I think it's both at the same time. But what do you think? What do you think?
My perspective, so for most tasks, most companies, they will just resort to whatever OpenAI is offering. So when I talk to companies who are non-tech, the reference of AI is what OpenAI is doing.
Yes.
And they have not heard of the llamas, the Strauss, whatnot. It's just, okay, like you're using ChatGPT, maybe my children is in ChatGPT or something, and then we have to do at the company something, so with OpenAI and so on. And I do think that this idea of maybe like prompt engineering of so like experts who are working with the models but who are not training model, it will become in reality, it will not become just like a niche, but it might be something for you. Will always need people who are able to train models from the beginning to an end, right? Like do something specific. As you're saying, so here, trying to have like on device, on the watch and so on, they'll have challenges like embedding that you were like doing so at HP and so on. You require like a lot of expertise. But they're thinking about, let's say, like the classical startup, so who is doing some internet application or doing like regular companies and so on, who already struggle trying to find a machine learning expert. They will just use cloud models, get results there, and maybe if there is need, they might want to specialize and try to find the help with it.
I completely agree. I think what ChatGPT in general has done to the market, which I really love, was made it more accessible, has made AI more accessible to the global market. Like for example, marketing companies that have never used machine learning now use machine learning everywhere. So I think that breadth of AI has grown because of ChatGPT. And then people who still want to like who want to focus in on a problem, that breadth has also grown because now you have more intelligence again. So I think basically the whole AI breadth has grown over time. And I think it'll continue to grow till we hit like human population limits.
Thinking on it's like a young Prass or anyone who aspires to become like Prass. What advice would you give of for how to study? So especially now we're discussing earlier, people can learn how to code with ChatGPT and so on. We usually say, hey, engineering as I did was like the right path, or say, no, actually these days, if I could like do these things again and so on, with what I know today, plus where I see where things are going, I will study something else.
So the one thing I might say is keep doing. Like learn is in a structured way. So continue this whole path of studies. As far as we know is this is the path, like this is the path of education, but never, I mean, not never, but try to start doing very early on. And today we have a lot of resources that help us do. We have Google Colab that gives us free GPUs. We have Hugging Face that writes amazing blogs, has amazing libraries. So start getting into that world and trying to do what you can do in that world already very early on in the process. And then one amazing thing I would say is just constantly use something like a chatbot, a chat GPT, an Anthropic, whatever. Keep learning,
Yes.
keep doing. You can, like the way I use chat GPT, I use it about 5 times, 10 times every day. Anything from like, hey, structuring some CSV data to like being my mentor. Like, hey, I'm going through this tough time at my job. Please help me out.
Yes.
So everything. So I would definitely use this AI companion now that I do have it and integrate it into my life, especially if I want to learn something, finding out the opportunities for it. I would use this AI companion to do it.
Yes.
And I think that merging of your formal education and your informal education coming from AI, that's going to be super powerful for our next generation. People will be more wiser in choosing their path much early on. I think people will know themselves better because they're going to ask questions. Like I know about my interest only at 35. Maybe people will know this at 12, 13. Like this is my superpower. That's on it. They'll be able to watch future future paths in the world, like how things are evolving with more clarity. And I think this is coming. And I think our next generation is going to be way smarter than us because everyone is going to focus on their superpowers. And I think that is going to be slightly perfect.
That's a very optimistic perspective. You also said you had some repositories that you can show up here to the audience, and I said that you were proud of. Was like a share.
Yeah, sure.
Yes, tell us a bit about your repository, Prass. What is it about?
I'm just going to show you my GitHub. Not too much about any particular repository. I'm just going to like show generally about various repositories. So there's one thing I'm building out.
So first, what's your GitHub ID? What can people find your GitHub, Prass?
My GitHub ID is Prasanna-Ravishankar.
Wow, that's a bit hard to spell for everyone.
Yeah, thankfully you haven't.
Yes, I will write it. I will put it in the show notes and everything. So
Perfect. Or you can find me at Prasanna.io.
great.
I actually have a blog about my journey, so feel free to read it.
Yes.
One of the things I'm actually working on is this thing called Project Q. And Project Q is a small web application. It's very early stages, and it tries to understand your personality from free from text. So it doesn't ask you questions. It doesn't ask you specific questions about your personality, but it uses ChatGPT, actually Anthropic, to understand what kind of personality you are. So I'm trying to develop this into a community. At the moment, it's 64 lines of code. A lot of it helped by Anthropic.
A community. So it means you're looking for support. Who are you looking for? Who should come and help me hearing your efforts?
At the moment, I'm just looking for a couple of fun coders who want to see where this goes. There's no specific thing. Someone who wants to learn about Anthropic APIs or LangChain, you can start using this because I'm using LangChain semantics over here. And I want to see where people take this project forward. The other thing I'm actually working on is Torch Web IO, which is a paused project because I did not have time to complete it. It's a front-end generator for any model. At the moment, it supports image processing models, and it's super simple, lightweight, and it turns any model into a front end. So right now, I've implemented integration with image classification. I want to implement more integration with computer vision models, and then move on to NLP models after that. So the idea is you can upload an image and it'll instantly generate the front end will be generated. You can upload it and you can get an answer, and you can code how that answer has to be. So this I created it so that researchers very early on can see how their model looks, how it performs, generally get an idea of the final stage, which is not the super final stage, but generally get idea of what it means to be in production. And I did this as a fun project, so I'm looking for people to extend these problem spaces that I have.
Yes. So anyone can check on your GitHub repository,
Yes.
check your repositories, and then join the efforts.
Exactly. And if you want to learn about machine learning, I have a course on GitHub as well, so you can check out that course.
You have a course on GitHub, really? Where is it?
It's called Machine Learning 101.
In the repositories, because we have so many of them. Another 45 repositories. That's amazing.
Many of them are fork repositories where I've just contributed back to the community. But this is a course on machine learning. But this is, if you want to start from the very basics, this is before the Hugging Face revolution. So,
Well, any final words of advice, Prass, that you have for any newcomer? So why wouldn't tell to anyone who's just starting with new?
I would say if you're into machine learning, just have fun, see where it goes, build the stupidest product, build the scrappiest thing, and actually enjoy the process. And then you would become a great machine learning engineer.
So then where can people find you? Already we saw your GitHub repository is one way. Also, you say you have a website.
I have a website called prasanna.io. So it's prasanna.io.
Okay.
And you can find all my other handles on the website.
So anyone should go and check it out and then reach out for any career advice, any tips, joining your efforts.
100%. And you can also find my LinkedIn over there. So if you want some career advice, some mentorship, I'm always happy to give back to the community because the community helped me become who I am. So anytime you want to contact me, feel free.
Well, thanks for your time, Prass.
Thank you.
This was our chat with Prass. And reflecting on it, it is fascinating because you can really see how Prass has gone through different phases across different regions and geographies, and nevertheless always driven by curiosity, always driven by adaptability, flexibility. And looking these days at Gen AI, at what's happening with our new developments, the latest in the space, we see how we as professionals need to evolve and become more and more like Prass, meaning not just stay fixed on a technology, on a discipline, on a region, but rather adapt. Because really, the future of Gen AI, it is for people who can be generalists. We're approaching a phase where knowledge is moving in a way that is harder for humans to stay competitive with an AI. But there will be so many things that an AI will never be able to match. And this means that if we stay malleable, if we stay nimble, if we stay flexible, there'll always be exciting opportunities for us. And what are your thoughts? What did you learn today? And as well, did you like the format? I gotta say, this interview, we recorded it a few months ago. One reason why we hadn't released it, it is basically because it was rather hard to edit. Too many things going on in the camera, too many angles, and so on. And the question is, do you like that format? If that's the case, let me know, because I really enjoy it. I like to do more of this type of recordings, of interviews. So let me know in the comments what you thought, and also if maybe after this interview, this discussion with Prass, then you're saying, hey, I might want to become a bit more like Prass. And if that's the case, then come and join aiproduct.engineer. Join our community, be part of it. And otherwise, let's tune in next week for another show of AI Product Engineer. Until next time.